wabarakatuh. My name is Farah Adib, and in this video we will be venturing the subtopic of Chapter 3, Application of Differentiation of MAT183 calculus, which are related rates. You will be guided by three of my group members, Alisa Firzana binti Abu Nasir Mat Feroz, Alina Rifah binti Cik Noh, and me, Farah Adib binti Fayaz Ahmad, throughout this video.
Assalamualaikum. My name is Alisa Firzana, and I will be presenting the introductions to you. In this section, you will be introduced to related rates from three ways. First, I will be giving you the brief explanation behind the history of related rates. Reverend William Ritchie was a professor of natural philosophy at London University. He had published a book on principles of the differential and integral calculus with J.J. Sylvester. He came up with the idea when he thought of an easy way to present calculus to students. This is because students are usually intimidated by differential and integral calculus. Next, James Connell LLD was the first person to reform related rates after Reverend William Ritchie. He was a Master of Mathematics department in High School of Glasgow. James Connell published a calculus book in 1844 to help school students. He also introduced instantaneous rate in his publishings. The next two persons is J. Minot Rice and W. Woolsey Johnson. J. Minot Rice is a professor of mathematics at Naval Academy, while W. Woolsey Johnson was a professor of mathematics at St. Johnson College. Most of their works are drawn from James Connell, as he was their heaviest inspiration. The simplifications introduced by these two had more impact, and as a result, related rates were taught in more institutions. Next, definition of related rates. What is related rates? Related rates is the solving of problems involving rate of change of two variables with time. Why is related rates important? It is important to simplify differentiable calculus. When do you use related rates? You can use related rates when you don't know the rate of change of another variable. How do you use related rate? You can use related rates in this example. Lastly, the solving steps of related rates. In step 1, you would need to identify the rate of change that is given and the unknown. Step 2, you would have to construct an equation that relates the variable in step 1. Step 3, differentiate the equation in step 2 implicitly with respect to time. Step 4, substitute the given values in step 1 into equation in step 3. Step 5, solve the unknown rate of change.
The street light is at the top of an 18 feet tall pole. A woman 6 feet tall walks away from the pole with a speed of 4 feet per second along a straight path. So how fast is the tip of her shadow moving when she is 45 feet from the base of the pole? So we have the diagram here. We can say let this be the pole, and in the statement it says 18 feet tall, and the woman walked away from the pole, so this is her 6 feet tall. So as you can see from here, so this is her shadow, right? As you can see here, there's a smaller triangle in a bigger triangle. So we can say this let this long line to be y and this shorter line to be x. So this another smaller line in a smaller triangle can be y minus x. So we read again the passage. It says here, we are a speed of 4 feet per second. So she walked with a dx dt is positive 4 feet per second. So now how fast is the tip of a shadow moving when she is 45 feet from the base of the pole? So we can say here x is 45 feet, right? So now what we're trying to look for is dy dx. So now what we're looking for is dy dx, right? So we need to find y. So to find y, we can see here there's a smaller triangle in a bigger triangle. So we can see this line corresponds to this line. So 18 over 6 is equal to y over y minus x. We can cut it down to 3 over 1 equal to y over y minus x, and we can cross. At the end we will get negative 2y equal to negative 3x. So divide this by negative 2, divide this by negative 2. We can say y equal to 3 over 2x. Okay, so this is the equation that we're going to use. Okay, so what we're looking here is for the derivative of y. So d dt y respected to t is equal to d dt 3 over 2x respected to t. So we are going to apply multiple chain rule on both sides. So here will be dy dt, and this is 3 over 2x 3 over 2 dx dt. So the dy dt will be it will be constant because dx dt is already mentioned here, so 4. So it will be 3 over 2 times 4 feet per second. We can cut this down will be 2, and the answer will be 4 feet per second. That will be the final answer. Water is draining from a conical reservoir at a rate of 50 meter cube per minute. So how fast is the water level falling when the water is 2 meter deep? So the tank is 5 meter tall with a radius of 45 meter. It says here the rate of 50 meter cube per minute. So here is the rate of change of volume over time. So it's 50 meter cube per minute. And what we're looking for is the water level falling when the water is 2 meters. So it is rate of change of height over time when it's 2 meters. So this is the conical reservoir I drawn. So the radius is 45 meter with a height of 5 meter. So we need to know the volume of a conical first. So formula for volume of a cone is 1 over 3 pi r square h. So we can directly do this. Will be pi over 3 2r dr dt times h plus r square dh dt. Okay, as the same as previous example, you can see here we can form a right angle triangle, right? And here, when the water is falling, there will be another smaller right angle triangle. So you can just draw it like this, and these two will correspond to each other. So this is 45 meter. So this is another radius, and this is 5, and this is h. So we can write it down like this: 45 over 5 is equal to r over h. So it's 45h equal to 5r, and 9h equal to r. So based on the formula 1 over 3 pi r squared h, we can replace our r. So it will be v 1 over 3 pi 9h squared times h. So it will be 1 over 3 pi 81h cubed. Okay, so now we're going to find the derivative of dv dt. So it will be pi over 3 81 3h squared dh dt. So we already know our dv dt here. So it will be 50 equal to pi over 3 81 3. We know our h here is mentioned here. So 2 square dh dt. So we can just solve this, divide this, cut this, and it will be pi times a1 times 4 dh dt. As I said, we here to find dh dt, so just remove all of these constants under this and we will get the answer. So dh dt equal to 50 divided by all of this. So pi times 81 times 4 meter per minute. That will be your final answer. Thank you.
A trough of water is 8 meters in length and its ends are in the shape of isosceles whose width is 5 meters and height is 2 meters. If water is being pumped in at a constant rate of 6 meter cube per second, at what rate is the height of 120 centimeter? At what rate is the width of water changing when the water has height of 120 centimeter? This is what it looks like. Given that dv over dt is 6 and length is 8 meters, we have to find the dh over dt when the height is 1.2 meters. We know that the formula for volume of triangle is length times width times height. So the length is 8, so 1 over 2 times 8 times w times h is equal to 4 wh. From the question, w over 5 is equal to h over 2. And from this, w is equal to 5 over 2h. We must insert the answer into the next step, which is dv over dt is equal to 4 times 5 over 2h. And we got dv over dt is 6. 6 is equal to 10h square. We must differentiate the answer, so we got 6 is equal to 20h times dh over dt. We have to find dh over dt, so 6 over 20h and insert the h, which is 1.2 meters. And we got 0.25 meter per second for the rate of height. We know that dh over dt is 0.25 meter per second. The next question, they want us to find dw over, and the height is 1.2 meter. From the previous question, w is equal to 5 over 2h. We must differentiate this to get dw over dt is equal to 5 over 2 times dh over dt. Insert the dh over dt, which is 0. So 5 over 2 times 0.25, and we got got 0.625 meter per second for the rate of wind. In this topic, we learned the simple ways on how to find related rates, which is first, we have to draw the described shape. Next, write the equation that relate to the information and then differentiate and substitute to the next step. And lastly, solve the question. Related rates can also be used in our daily life. And these are the references that we use to find the information. That's all from us. Thank you.